Hello everybody, this is Srinivasa. I am working as technical architect in UBS. Prior to that, I worked with Cognizant and I worked with different clients like Amex, Broadridge, like financial organizations, and especially in wealth management system. Okay, so today I'm going to give a demo on JavaScript vulnerabilities. Let's start. Let me share the screen. So here is my screen. So securing JavaScript, which means how we need to protect our code from external attacks. So it may be either front-end related or it may be either from back-end related or it may be either from any other tools or libraries, any other components. The security challenge is here. Okay, so nowadays many people are using front-end applications as well as back-end server-side components. The attack can come from any point, in the sense like from the front end or from back end. Front ends React, Node, back end like Node.js. So there is a lot of opportunity for the attackers to create a lot of attacks and vulnerabilities across our different frameworks, across our different APIs, and across the different components that we are using. So the normal traditional security approach, so they do not all the vulnerabilities. Definitely we need a some sort of patterns, some sort of mechanism to address all these vulnerabilities. Let us see. Okay, so we will cover JavaScript attack landscape. So which means what are different ways of threats, and second, vulnerability management framework, how we can mitigate those issues. Front end, and third one, front end security patterns. Definitely we can protect our code by following some patterns like design patterns. Node, fourth one, Node.js security. So how we can manage our backend code with using some sort of specification. And fifth one, automation and integration. So automation and integration means everything is like automated, so it's like workflow and components are integrated, so that is process. And risk based patch management, if there are any issues, immediately identify that and apply some patches, something like that. Okay, as I said, common JavaScript attack vectors. So if you consider DOM based accesses, cross site scripting. So this is one of the major vulnerability attack that our code base is facing. What it means? So it means, for example, in JavaScript or front end code, if we are retrieving some value from the URL, for example, a name or designation or anything, okay, and you are including that as part of inner HTML, you are making those values into some document, and you are trying to execute the application. So this is like a bad habit of coding. There is a lot of scope that external attacks can happen. So this is one of attack that can happen. And second thing, prototype pollution. So prototype pollution means, for example, so you are creating a JavaScript, for example, in the sense window dot location. So in that case, it is harm to read those values, and definitely there may be attack from external site, external people. Dependency confusion is like, for example, in our application, lots of components we are downloading for Maven's website. So lots of components we are downloading. So attackers want to create a confusion between the original component and a harmful component. So they want to make use of similar name, pom.xml components, and try to expose those components into the public websites, and in turn people can download that and try to install and try to put their components in the application. So obviously that's a big attack. And another one is server side injection. Server side injection is nothing but the code will execute to interact with the database. So definitely there is a lot of scope. If the code is not written properly, there is a lot of code. They can manipulate SQL queries, and they can include the values whatever they want. And even non-SQL also they can manipulate, and they can attack the data, they can get the data, they can manipulate the data, they can delete the data. So there are lots of possibilities like this the externals can attack. Okay, so now what to do? We can we can get a vulnerability management framework. We can use some sort of frameworks, good frameworks, where we can it can handle all these sort of things in appropriate way. So it first it assessment. So it identifies and quantifies the risk across our JavaScript stack. And prevention. So it implements some security patterns, and some controllers, some security related admin roles, something like that. Detection. So it continuously monitors and automated the scanning. For example, if there is any code which is vulnerable, immediately it gives alert. So it continuously monitors, and it gives an alert if there is any issue, and instant workflow and patch management, which is in the sense if there is any incident happened, immediately it applies related patch. Now let's see quantitative risk assessment for some sort of dependencies. Evaluation criteria. So vulnerability history, it tracks the fast security issues and resolution times. How many issues are reported? What are the resolution time? Within what time it has been resolved? So it gets all the history of that vulnerabilities. Maintenance activity. So monitor commit frequency, issue response, and active maintenance. So it frequently monitors what is the code committed, who is the code committed, and when it is committed. So what are the impacts of that commit? So whether it can be removed or not. So dependency chain depth assesses translative dependencies and their security posture. Download metrics evaluate community adoption and security levels. Another one is automate auditing tools enable consistent data-driven security decisions across the JavaScript projects. Front-end coming to the point of front-end security client-side defense. So how these are all the points how to mediate or how to manage those vulnerabilities. So if you consider XSS, right, cross cross-site scripting. So these, for example, these externals can attack by giving some dummy values or some image or some path to image in the URLs. So when the code tries to get that particular value, the attacker included an image which is not secure, and our code tries to get that image, load that image, or it may be something like that, any link or something which is obviously it is under attack. So second one, secure API communication. So we have to use proper HTTPS, implement proper policies, and especially validate all the data. So what is that data? Input validation, simple input validation, what it contains, what are the required values, or what are the mandatory values that contain. You cannot simply pass through. So definitely you have to validate all the data received from the external source. Input, third one, input sanitization, which means before you do document or using any others, so use some validation libraries, and use some specific formats where user can give, and we can validate the data. Especially the fourth one, authentication security, security token, as you can use certificates, you can use tokens. Okay, so using that we can definitely now secure our website. React modern frameworks, and we need to consider a word dangerous self inner HTML. This is very important point. Okay, when there is a necessary to use DOM, okay, we can use Purify or similar any other libraries which can sanitize data before we render to any other web pages or to backend. And validate prototypes or typescripting to enforce type safety and prevent unexpected data flow. Okay, carefully manage the data flow between components and validate the data at boundaries. Okay. So Node.js backend security, secure coding practice. There are lots of things here. So input validation, whatever the value received from your request parameters, or else you need to validate, and especially parameterized queries. They can, in query parameter, they can give some value is admin true, or they can give some account number, wrong account number. They can put some account number to deposit money or to withdraw or something like that. They can manipulate the SQL queries, and then it tries to execute at server side. So definitely we need to validate all the input data that we received, and proper exception handling, especially without exposing whatever it comes. Before exposing, we have to put proper exception handling message, and secure authentication, authorization, and rate limiting, and request throttling. So runtime protection, environment variable securely. We can use different environment variables, so we have to use all those in a secured way. Okay, and principle of least privilege. Okay, and if there is a need, then only give the roles and responsibilities, roles in the sense. Okay, so secure dependency management and regular security audits with npm audit. So container security for JavaScript application. Minimal base images. Use appline or shoulders images to reduce attack surfaces and eliminate unnecessary packages. Non-root user. Run Node.js process as non-privileged users within containers to limit potential damage. Integrate vulnerability scanning into CI/CD pipelines to catch issues before deployment. CI/CD pipelines is a major workflow management system. So definitely we can automate all the code to avoid any issues before the deployment. And never bake the secrets into images. Use orchestration platform secret management instead. Okay. So automation throughout the development. Pre-commit, in the sense before we commit the code into Git repo or whatever it may be, scan for secrets. You have to make sure that there are no credentials or passwords related issues, vulnerability issues before code goes to repository. Okay, and pull the request. Automated dependency audits the security and test execution for every submission. and CI/CD pipelines integrated into build and deployment process, and then continuation monitoring, runtime application, build, log analysis, and deployment to production. So risk-based patch management matrices. These are many things here. Okay, so critical 0 day, immediate patching within 24 hours, active exploration in the wild, which means if there are any instance or anything, immediately we can apply patch so that it can come to normal position. How high severity. So patch within 7 days, known exploit, high CVS score affects production. Medium risk, schedule within 30 days, low priority, include runtime maintenance, minimal impact of the required local access. So types of scripts role in security. Type safety prevents common vulnerabilities, which means static typing caches, type config issues, prevent prototype, pollution through stricter objects handling, and enforces interface context at compile time. Enhanced code quality. There are lots of sonar, for example, sonar cube. Okay, sonar cube, it gives all the code related issues before we commit the code. So if it passes, then only we have to put a condition in the pipeline, stop deployment or stop proceeding to commit if it identifies any issues, vulnerability issues. Okay, not a silver bullet. TypeScript does not replace runtime validation, security testing, or secure coding practices. It's one layer of the defense in depth strategy. Okay, so these are the points that we cover. Adopt a framework mindset. Okay, secure is not a checkbox, it's a systematic approach spanning assessment, prevention, detection, and response. Automate everything possible, yes. Avoid manual process. For example, do not use any manual created passwords. Automate it. For example, if you consider cloud, it automatically creates the password. Nobody knows it. It automatically creates, it automatically works. That's it. Nobody knows the password. Okay, and especially nowadays, even that is also going away. There's no password, just based on the user entitlements, user roles, we can for the website browsing. Priority the intelligently. Use risk-based patch management to focus efforts where they matter most without security. Think full stack. JavaScript security requests protecting both front end and back end. It's not only front end, it's not like only back end, from end to end application, and controls the each thing. Thank you very much.